So let's do it. So let's create a first model. Okay? Let's demonstrate the buoyancy force. So what's the buoyancy force? Buoyancy force comes from Archimedes' principle. And what you essentially do is you compare the weight, same volumes of an object and the fluid around it. Okay? And this weight per volume is called density. And so what you do is you compare the density of an object with the density of the fluid, okay, of the same volume that you compare. Okay, you divide that by the density of the object, multiply with acceleration due to gravity, and with a minus sign, you get the buoyancy force. The minus sign is there because of our definition of the vertical axis. It points upward, and the buoyancy force, this is in a negative buoyancy, points downward. If the object density exceeds the density of your fluid. Okay, so that all makes sense. What we also want to do is we actually want to consider a situation where the density in your fluid varies linearly from the surface to the bottom of your layer of fluid. And in order to do that, you can use something that is called stability frequency. And this is how it is defined. It's this one. It's called n squared. It's actually the square of a frequency. You'll learn more about that in the following. How it is defined. It's minus. How does the density change with depth? This is the vertical gradient of density. D rho dz means how does density change with depth? And then this is just multiplied with acceleration due to gravity. It's a constant. And a reference density, or the mean density, which is a constant. Okay, so now you can have different situations. For example, if density does not change with depth, means we call it neutral. Okay, this n square is equals to 0. If it's a positive number, it's stable, which means lighter fluid above heavier fluids. If it's less than 0, we have so-called unstable situations, heavier fluid over lighter fluid. Okay, and the density is the weight per unit volume. And this is what we want to use. Okay, so we want to place an object of a certain weight, of a certain density, into a fluid that is linearly stratified.